Okay, welcome back from the lunch break. So I hope you all already had your coffee to go through the last part of the conference. I'm Raivo. I will be your moderator for the next part of this session. Our next speaker will be Shekhar Ramphal. He will talk about 5 phases of API test automation. Shekhar is passionate about software testing. He has computer engineering qualification. He is experienced in full stack testing in all areas from manual QA, system design, architecture to performance and security, as well as automation in different languages. Okay, Shekhar, the floor or stream is yours.
Hi, thanks for having me. All right, let me get our slides going. I can't see anything on my end. No worries. Yeah, guys, let me just tell you about a little bit about myself. So like I mentioned, my name is Shekhar Ramphal. Come from Cape Town, South Africa. Like the moderator kind of mentioned, I have a bit of a background in computer engineering, and kind of testing was my first job. So this is kind of the passion that I have and the thing that I love. And this is what I've been doing now for the last, I think it's been probably like 15 years now. So yeah, I'm currently working at a company that does long-term investments. Company is called Allan Gray. We're basically a fintech that does an online presence for our users to log in and transact and be able to trade their money and invest as they feel fit. Yeah, let's just go through this. Yeah, as I said, for a couple of years experience. Yeah, and I do see myself as kind of a full stack tester. I don't kind of prescribe to all the different kind of software titles out there. I know there's a few of them. I feel like testing should be done by everyone and done across the stack anyway. And I feel we've been doing that for a good few years. So yeah, I just got it as full stack testing. I think it's important to lay down the context around like kind of what my environment looks like and why we've kind of chosen the approach that we've gone with. So what we have is multiple Scrum teams. There's about 25 different Scrum teams, and it's a full kind of microservice architecture. The way we kind of manage that is that each of the teams kind of contribute their services or microservices into a single kind of development area or development environment where testing happens. Obviously, there's a lot of like coordination and a lot of pros and cons to this approach. So we definitely have our issues there. And some of these kind of testing approaches, especially with the APIs and microservices, is to kind of combat those things. So yeah, that's what the environment looks like. Teams kind of throw their services into the environment as and when they're ready. Database changes, infrastructural changes, services, functional changes as well. And there's a lot of dependencies between them. So each of the domains or teams kind of look after their own domain. So like team A, for example, might be all the banking data, whereas team B or C might be the client data, and then team D might be transactional data. And given all of their different domain knowledges and their different services, that all gets thrown into the environment, and then we can kind of do testing there. These also, yeah, like I mentioned, happen like ad hocly, so they don't, they're not like scheduled and kind of governed by anyone. The main kind of reason is that we want development to be rapid and to be agile, so that teams can kind of influence their own kind of pathway in terms of how they deliver software. In terms of my automation approach and the automation approach that we've taken, so ours is very programmatic in nature. We don't try and stay away from like a lot of proprietary tooling, mainly around the reason that we're trying to avoid those kind of big roadblocks where somebody says, I don't have that version of Java installed, or I don't have that tool installed, or I don't have that license as per se. So we try and stay away from that and try and have a very programmatic approach. The code also that we develop lives within the feature code. So we try and stay away from having any test code that runs outside from the feature code. So if you have a repository where you're building a microservice, all the tests should live in that microservice. And that way, the kind of tests and the feature code move together. I think it's also important to kind of have a framework that's kind of easily maintainable and like kind of caters for testers at different levels. Obviously, the more technical guys will want to have like quite advanced functions and kind of like custom methods to be able to do the things they need to do. But that's kind of like where we kind of strive on consistency being important, so that when the testers are moving from repository or to different services, or maybe even to different teams, they can effectively kind of manage their own kind of delivery of that. So that's kind of the key thing there around consistency. Yeah, so we also see automation as a tool, as not as like the be all and end all. So it's not the goal; it's just a tool to kind of enhance testing and to kind of something to have and good principles around that, so that testers don't see as like, I've written one automation test and I call it a day. It's kind of doing due diligence on the testing processes that you have been trained and taught to do, and just using automation as another way of being effective and to be efficient at what the job that we're trying to do. So trying to explain this is a bit difficult. So I think the easiest way is to kind of look at it, could look at an example, especially with APIs, because I think everyone's quite familiar with how APIs look and how they function. So let's take you through my example here at the moment. Cool. It's a bit blurry, but that's all right. So if you look at this is our language of choice that we've chosen is JavaScript. So excuse me for those Python and Java fans if it looks unfamiliar. But yeah, so this is, you can see that the definition is just a URL. This is like a search endpoint to search different people. You invoke the request with a URL and you check a response code. So that's a typical kind of API test that you would normally see. When I look at that, I mean, like I see a bit of like a few problems with it. So the one thing I notice is that, like, I actually need legitimate data. So in order to search shakes, I need to have like a person that exists with shakes in the database, so that this API will return a good response. So that's usually a problem for testers, is a big one, test data. Yeah, APIs, it's sometimes different response codes. So it's saying API, touch someone that's not in the database, I probably still get a response to 100, just probably with array or something like that. The other thing that I noticed, which is a fairly big API, already be developed and has to be in the development environment for me to actually run this test, which is a problem because it's kind of gone through all the design phases and all the analysis phases and all the kind of implementation details. And now I'm coming at the tail end trying to automate it. Like I said, you probably want to add a bit more validation there around maybe the body length needs to be greater. Maybe you want to actually check that the response name is equal to what you passed in. And yeah, the last one is like, you probably want to check people that have weird names and weird data, special characters and things like that. So for me, there's a few things going on with this kind of simple test. So the other major one, obviously, in a shared environment is that when you have lots of kind of people contributing and a lot of 20 different teams contributing their services all the time, it's very likely that things might go up and down. So this API could have worked 10 minutes ago when you wrote it, and then you push it into the pipeline and come grab a cup of coffee, and you come back, and then you notice that, like, yeah, it's not running anymore. So that's something with environment consistency we usually have a problem with as well. So the way that I look at it, kind of ask these questions to myself around what type of test that I'm writing, what data am I using, and where do they run, when do they run. So I've broken it down into these 5 different kind of stages or levels or phases. The first one is kind of industry standard around component tests. We just rebranded it acceptance tests because I feel like that's where the acceptance criteria kind of happens for this API. Or this kind of level of testing. Then integration tests, which we kind of call verification tests. Smoke tests, kind of industry standard there as well, around tests that happen post a deployment. Synthetics tests we stole from the monitoring world, around some tests that run periodically and make sure that they're checking that the environment's stable. And then data chaos monkey test is something that I came up with, where we actually look for random data in our production environment, or and try and find different data scenarios that we might not have thought about, and then try to call the API with that. Obviously, the assumption here is that you're still doing unit and integration tests and unit integration tests. This is not replacing any of that. This is like developers there should just also do due diligence to make sure that stuff is still happening and all the static analysis and all of that. This is just over and above. Yeah, so these are the kind of questions that we're asking at each of those levels. I mean, at the acceptance level, we're trying to say, like, does my code do what's expected of it? At integration level, I want to make sure that given the number of microservices talking to each other, do they actually integrate with each other and can talk to the right version at the right time? With my smoke test, you want to check that after you get to actually deploy the code, it's going to work. Like I mentioned with the synthetics, you want to make sure that the environment is stable, and then the data permutations. Cool. So this is a typical like diagram of what our infrastructure looks like at the moment. So the orange API in the middle there being the API under test, and all the surrounding dependencies would be other APIs or a database or maybe a message queue system. And then our test suite kind of sitting outside of that API and talking to it on the inside. In terms of what we do to kind of isolate this orange API as much as we can is we rip out all of its API dependencies and we put in like a network proxy. And in that way, we can reply with any kind of mock data that we want for a particular scenario. Similarly, with the message queue system, we'll start up our own and have our own separate database to talk to that API. So that API is totally isolated from the outside world. And then the test suite is the only thing that can talk to it. In terms of technologies, like I mentioned, we use JavaScript and Jest to run our test code. And that's all built into a Docker container. Similarly, with our APIs, we have a multiple number of languages that we do our APIs. We leave that quite up to the developers to pick language of their choice. We have Python and Java and .NET, but our main 2 languages that we write services in are Golang and Scala. And that's also wrapped up into its own Docker container. Similarly, our proxy is, and all of these Docker containers are then spun up in its own Kubernetes cluster that can then be isolated from the rest of the world and communicate with each other. So we get past the language kind of barrier with using Docker and Kubernetes as our form of kind of communicating between the stacks. Yeah, so the example here was like if somebody wanted to, so say the same person API needs to collect information from a number of different downstream APIs, bank details, contact details, account info. The things that you would possibly test in here would be like all the different kind of permutations that you could think up as a tester. So traditionally, if you were trying to do a post or a delete in a shared environment, you might be deleting somebody else's data or creating nonsense data or corrupt data that could affect the rest of the environment. So doing it in this fashion kind of isolates you from that. You can also simulate things that you couldn't necessarily simulate in a shared environment, like if bank detail API was down, so I wanted to return a 500 with a server error, you could easily mock that out, and then the orange API under test would have to see how it handles that. Whereas in a shared environment, I would have to possibly call that team and say, hey, can you please shut down your API for 5 minutes? I need to check something, which is not really feasible in the automated world. Cool. So automating it, I mean, this is kind of like what the test looks like in terms of invoking the dependencies, calling the API, and you can see there the difference is we're starting up a local API that's running in its Kubernetes environment. or we could possibly pull down that Docker container and start it locally on your machine, because that we kind of also remove that it works on my machine kind of thing, by using Docker containers as a shared environment. And that Docker image that we test on is the same Docker image that will get shipped way through to production. The other cool thing that Jest allows and most languages allows is that if you're controlling the outputs and the inputs, then you can just take a snapshot of your entire response rather than asserting different things. So here we just take a snapshot of the entire response and we can test against that. So writing the test becomes quite quick instead of trying to like think about the particular assertions and things that you might do. Yeah, so it's all fake news though, right? Like you can't kind of sign off this just with mocked out tests and let it go to production. So we do the next level of testing, which is the kind of level of integration testing where we actually want to talk to real services. And here we test mainly the integration points. We test kind of the 80-20 functionality, meaning like the most critical functionality. And here we also isolate the ring fence environment. So we use GitLab as our tool of choice for deployments. And this talks to a Kubernetes cluster in the background. So we can very quickly like isolate the entire environment in a Kubernetes namespace, and then start up all the relevant Docker containers that we need for the integration test. These API, the Orange API would also have like some kind of configuration file, would tell you what its list of dependencies are. So we know exactly what to spin up in order for it to work. And then we'll run the test in the same way. In this case, like I mentioned here, we'll hit all the critical dependencies. We'll try and test all the critical functionality. And then the other thing that we do at this level is contract testing, because we actually want to talk to the downstream services or the dependent services, check what the response is coming back and make sure that the contract's satisfied. And that's quite nice to do at this level. So you catch quite early on what kind of dependencies have changed their shape or changed their contract in some way, shape, or form. So after these two levels are kind of done, then we push it into the testing environment. And I guess a lot of the time, I'm not sure whether other people have this problem, but we have this inconsistency where the deployment tooling works and everything goes green and it says, hey, your thing is in the environment. But then when you actually get there, it's not working. So that's where smoke tests come into play. So even though your deployment's green, we run some kind of sanity checks around making sure that that is still stable. So once it's in there, this gives our testers some time to kind of explore the API, explore the integration points, and make sure that things are working as expected, given the versions that were deployed. And it's some time here to be quite creative and stuff and try and come up with different things. Once it's kind of gone through that exploratory phase, we're then ready to push to production. So the one thing about automated tests is that a lot of the time it's run only while that service is in development. So the question that I had was like, so what if my service is quite stable and I haven't changed this banking API or this person API for quite a while? That means tests haven't ran. And that means I'm almost taking it for granted that it's still working as expected. But as we know, like things change, environment changes, ecosystem changes, patches happen, data changes, security changes. So what we want to do here then is run synthetics tests, which is tests that run periodically. So every 5 minutes, 10 minutes, hit an endpoint and do very light verification to make sure that you're actually getting back a response. So this is just make sure that your system is healthy. And what we do here is we kind of optimize the test a little bit. So instead of searching, so say the letter S and getting back 10,000 responses, we might want to search something specific to get back a small response in the quickest response time so that we don't put too much load on the system doing these kind of periodic checks. Yeah, and all of this happens in GitLab and it runs all the time. So GitLab allows you to schedule these things, which is quite cool. And we don't really have much monitoring tooling in the dev environments as we do in production. So that helps. And like I said, it's important to do these synthetics tests because there might be changes, not on your service particularly, but on the entire ecosystem around you. This also like changes the culture of the teams a little bit, because the teams have to be a bit more aware about the state of their service. So to combat this, we have dashboards within the team using Prometheus and Grafana, so that at each point in time, the teams that own a certain service will know whether it's healthy or not, and then they can react accordingly, so that if they are stakeholders or testers doing some exploratory testing or demos and things like that, that all goes smoothly. Cool. So with the data chaos monkey tests, this is kind of something we found that's inconsistent. Sometimes in production, as much as we as good testers and analysts and devs think about all the different permutations and scenarios that could possibly happen, our users always seem to create like some weird data scenario that we haven't thought of. So getting random data out of the database and invoking the APIs with that in that way kind of helps us catch those things. It's kind of like a cheap way of exploratory testing. And the way the test would look differently would be something like this. Would be where you would actually in the first line there get like a random name from the database, get that user's ID, and then use another guy's name from the database, and then update the original person with the second person. So in this case, I'm getting two random names and updating one with another for the person or for a client. I'm basically trying to test that we can update data correctly given users that actually might exist that we haven't thought of. And this is quite cool because I mean, like 99 times out of 100, this is probably going to be fine. But that one time that it does fail, it leads down a road of investigation and try and figure out, we don't really actually know our users. And then we investigate and figure out, okay, we need to start catering for that kind of thing, and or maybe validating it better. Cool. So I think like some of the major things is like, how does this kind of work on a day-to-day? And I think it's important to kind of understand the details of what your endpoint is doing. Ask these questions around which databases that it talk to, what views, what SPs, what other dependencies it has. I think a lot of the time testers get the service once it's already deployed in an environment, and they don't really have much visibility on the stuff. And having these like mocked out or different layers of testing gives you visibility in that, so you can design your test plans better and test in the right places. Other question I get asked is like, how do you actually do this in sprint and like make sure that there's a lot of automation happening across all the different levels. So the one thing Jest allows you to do, and I'm sure most of the other testing frameworks do, is you can come in on day one and kind of put in these to-dos and kind of share with your team around what are the different permutations that you would possibly test. And I would go back to my desk like after a sprint planning session and go commit this in code, and then some developer will have to review it and merge this in, and then it actually becomes their duty to then fill it in as well if I'm not available, or if a tester is not at that level where they can contribute to the automation. Then the dev will actually go in and start moving these tests around and be like, okay, I've unit tested the top 3. The other ones will do at integration level. The other ones will do at acceptance level. So it's just a kind of a little bit of a TDD style to influencing them around like good quality and what good test cases would look like. This is what our pipeline looks like in GitLab, which is which kind of at any point it has to pass a certain point before it can get into production. So the cool thing there is like once those Docker images are built and the static analysis is done on the initial build, that same Docker image, like I mentioned, gets shipped through all the different parts of the pipeline. So the verification and the acceptance test uses the exact same code base, and then similar for the smoke and synthetics and chaos smoking tests. And then just to touch on again, like what are we testing at the different areas and why they're split up the way they are is that we're testing the functionality with acceptance, we're testing connectivity with the verification tests, we're making sure that kind of deployment works with the smoke tests, and then stability in the test data. And then, yeah, just a little reminder on like the questions we're trying to ask. I think it's important. Like, I think testers usually speak in questions. So if somebody has to mention why we're doing what we're doing, and I think it's important that we're asking the right questions at the right phases, rather than trying to catch everything at the end, post deployment. So for us, making sure that what's expected of our APIs and that it integrates well and that our deployment is successful is key, to be able to deliver and have kind of a pipeline driven culture where the teams can have faith in their pipelines and with little manual intervention as possible, then like kind of move into production and then have the next iteration. And that's kind of all I had for you guys. Hopefully that made some sense.
It definitely did. At least I enjoyed it really, because microservices
Had
is
to
like
rush through it.
becoming
Yeah,
more
it's a
and
lot,
more.
lot of information.
No, that is true. That is true. But yeah, I really enjoyed it because this microservice architecture is becoming more and more popular, more trendy. It's really good to have some
Yeah,
practical tips and kind of a framework to think about it. Okay,
yeah,
now
totally.
it's time to get to questions.
All right.
Okay, I have some organizational questions. Like, how are the teams and services related? Like, is it like each team has one service, or is it each team has a domain, or several services? Or any services have multiple owners?
Yeah, so we try and have the team per owner, I mean, service per team kind of ownership. And that just gives us governance, but they are domain specific. So, say the reporting team, for example, would have a whole bunch of reporting APIs. The banking team would have a whole bunch of banking services, similar like with client details. But the kind of caveat is that the teams can, they're allowed to develop code across anybody's services. So it will. So if I want to make a change to the reporting API, my team would go in there, put in the merge request, and then assign it to a developer in that owning team, and then it kind of gets handed over, and then it becomes their responsibility going forward. So they have to hold me accountable for the new endpoint that I put in or the changes that I put in, making sure that I've written all the tests in the right places. And then obviously the pipeline will catch any kind of regression issues that I might have introduced as well.
Okay, makes sense. Uh, but how are the team responsibilities in regards of Docker images, CI/CD things? Like, up to what level do they control everything? Do you have like CI/CD team, or
No, so they control end to end. So from inception to like from the way they design it and implement it, and the pipelines go all the way through to production. So the CI/CD is designed in a way that those containers will move through the environments and get shipped to production. We did put some rules in place around like who can click what buttons. So there will be like a tech lead kind of product owner or domain owner discussion around, okay, this is the version that we want to release to production today, or this is the hotfix that we did. And then they'll sign off on, they'll have that discussion, and then one of them will click the button.
okay? Well, one thing with this having a lot of services is, do you have API versioning as well? Like,
Yeah.
if my API develops over time, you have to be backward compatible and so on. How do you handle this, and how do you test it?
Yep. So the cool thing with having the test code inside the feature code is that the tests move with the version changes. So as the breaking changes or version updates happen, new tests have to get written and old tests get removed in that way. We do use like semantic versioning, standard like kind of major, minor breaking releases kind of versioning, and we kind of try and stick to the latest version compatibility. If there is a breaking change, we try to communicate that quite heavily with the dependent teams, and that impact analysis is usually done up front. If not, and if the change is significant, then we'll hide it behind feature toggles until the consuming teams are ready to consume those new features. And then, so the new version will get released, it'll be behind a toggle, and then when the consuming teams need it, we'll switch the toggle off or on dependent on that. But yeah, it's a lot of management there in that sense. We try to stay away from breaking changes, obviously quite difficult. In that sense, over communicating, I think, helps with the consuming teams and understanding your dependencies.
Okay, that kind of leads to my next question, like managing all the contracts between different APIs and different teams and managing breaking changes. Like, in a sense, microservices introduce a lot of overhead in management. At the same time, it gives the flexibility of, I don't know, deploying on demand one concrete service. Like, how do you see, is it like, which side the benefit is? Is it
Yeah, I don't think it's one or the other. I don't think there's a silver bullet here. I think with the microservices trend, I think we jumped on probably about 6 years ago. And obviously, a lot of these things weren't like properly ironed out and thought through really well. I think generally with industry, but it's definitely something to consider is like good semantic versioning and version control and what processes you're going to put in place over and above that. The one approach that we also adopt quite heavily is actually duplicating endpoints and calling them like a V2 endpoint, so that in that way, some teams can point to V2 and some teams can point to V1. So we actually will sometimes have duplicate endpoints and then phase one out over time, or have like a deadline, or give teams a little bit of leeway so that they can migrate over to a new version. And that's one strategy that we've also played around with. But yeah, I think there is a lot of room for improvement there.
okay? Another thing is, have you tried this kind of deployed stage deployment, in a sense that you deploy your changes only one region or only one instances, and you later update other instances, or a
Yeah,
rolling
you could do
deployment?
that. Yeah, and target different users and things like that. I think that also you'll then need like some kind of management tool to figure out which versions are pointing to which place and when you need to grading and downgrading all the relevant spaces. So even there is some process and management.
Okay. A little bit about data and users being crazy. That was one of the comments, that they like that your users are crazy. How do you handle test data? I mean, like, you mentioned that users create crazy data in the production, but do you somehow mirror it back to the production, the test or development environment, or how you keep this kind of relationship?
Yeah. So in the financial world, obviously we can't have an exact replica. So what we do is we mask and scrub the data before it gets into the test environments. So we do get a copy of production, but then we randomize and scrub the data so that it's basically like not readable, or we can't relate it to the actual user in production. But it is relevant for us in terms of data scenarios. So like things like say the sequence of events that they took in place to get R, we might be able to follow, but we won't really be able to determine the user specifically. So in that sense, yeah, we do have a copy of production data, and we in the library that we've written, we pick off the dev environment and look at that data specifically for the thing that we're trying to do. So in this case, the example that I used was like searching people. So we try and have individual databases per microservice. So the people API will have its own people database. So in that way, it's like a one-to-one relationship. So I know exactly where I'm targeting, versus some of our information might be in the data warehouse and third-party kind of databases. But having isolated databases per API or per service definitely helps with that problem. So we can manage it quite.
Okay. How often do you do synthetic testing?
So yeah, like I mentioned, I think for us, it depends on the service. So critical services, we try to do like every 5 and 10 minutes, they'll be running weekly. Less critical services like I don't know, something that maybe not hit so often by our users, might be every half an hour or an hour. But the configuration of it is dependent on the team, and we let them kind of decide what makes sense, dependent on the criticalness or the riskiness to our users.
Okay. And on what basis do you generate the data for chaos monkey testing?
So it's more on scenario basis. So if I need a scenario where I'm looking for, say, a guy with extremely long name, then I'll write that query to get a certain name with a certain length or something like that. On somebody that has maybe zero balance in his account, then I'll write this query to be able to query the transactional details on him and make sure that he has no money in his account. But the query itself will return a random account every time that satisfies that specific testing scenario.
Okay, thank you. It seems that's it with the questions. So thank you for your interesting presentation. I think I got a lot of new ideas from the presentation and from the questions that were asked. Everybody, please provide feedback through our share track. So Shekhar, we will forward it later to Shekhar. Please remember to rate the track and ask more questions. We can later forward them as well. And of course, Shekhar is around and you can contact through chat. And visit our partners area, see what they are up to, because they are the ones who help us to put together this conference. And now we have a couple of minutes before new track. So grab a coffee, stretch yourself, and see you soon.